Hello friends, we are going to discuss the concept of vector from A-level syllabus, and I have taken a problem from A-level past paper. Now the problem here is, in the diagram O, A, B, C, D, E, F, G is a cuboid in which OA is 2 units, OC 4 units and OG 2 units. Unit vector I, J, K are parallel to OA, OC and OG respectively. The point M is the midpoint of DF. The point N on AB is such that AN equals to 3NB. A part. Express the vectors OM and MN in terms of IJK. B part. Find the vector equation for the line through M and N. C part. Show that the length of the perpendicular from O to the line through M and N is root 53 upon 6. So now we will start the solution. Here in the figure diagram it is already given that this is your cuboid. So cuboid and your OC is 4 unit here. So this is your 4 unit, OA 2 unit and OG. This length would be again 2 unit. Now first we will find the vector OM. So basically OM would be considered as your position vector. The coordinates of O would be origin and the M coordinate we will have to find out. Now in the diagram the coordinate of M would be here. Since M is the midpoint here, so the coordinate would be 1 here, while in the case of OC which is 4 unit, your point is again considered as midpoint, so that would be 2 unit, and your point M is through the from origin to the top, so completing this 2 unit, so that would be, so therefore the coordinate would be 1 2 2, and in a vector form we will write I plus 2j plus 2k. Now we will find the another vector nm. So mn vector would be, we will have to see the coordinates here. So basically the change, so mn vector direction would be this, from m point to n point. So here first we will see your unit vector in along the I direction. So along the I direction the vector would be I, then along the j would be again 1, so that is plus j, and since it is against the direction of the k vector, so it would be minus 2k. So this is the solution of A part. Now we will proceed to B part. In B part, we have to find the vector equation of line through M and N. So we will be writing R equals to, any point we can take it here as a position vector. So I am considering the coordinate of N point. The coordinate of N point would be 2i plus 3j, and since the N point is on the base only and the same plane where the O origin is there, so the length would be, the k unit would be 0 here, plus lambda times your mn vector, which is I plus j minus 2k. So this is the solution of your B part. Now we will proceed to C part here. In a C part, we have to show that length of the perpendicular from origin to the line through mn is root 53 by 6. So now here we will have to consider the point, because we need to show the length of the perpendicular from origin to line. So from this point to this line we will have to see the perpendicular. So the figure, if you try to make it here, then the figure would be, this is your line and this would be your considered as your origin. This is your O point, this is your M point, this is your N point here. So we will be considering this is the point where the line is perpendicular to Mn. So now we will consider here one point in terms of lambda. So we will be writing 2 plus lambda, another is 3 plus lambda, and then minus 2 lambda. So this is the point here. And now since we are looking from the origin, so this would be considered as a vector also. Say if I am saying let this point is P here, then the OP vector would be 2 plus lambda, 3 plus lambda, minus 2 lambda. This is your OP. Now we need to find the lambda here, and we know that the OP vector is perpendicular to the vector Mn here. So when this is perpendicular, then OP vector dot product with Mn vector equals to 0. So now the direction vector of the equation Mn here, so we will write here 1 into 2 plus lambda, so it would be 2 plus lambda plus 1, so 3 plus lambda, and then multiply here minus 2k with minus 2 lambda, so it would be minus minus plus 4 lambda equals to 0. So now you can see here you will have lambda plus lambda would be 2 lambda, and here is a 4 lambda. So and here you will have 3 plus, so this is your 5 plus and 6 lambda here equals to 0. So lambda equals to, you will be getting here minus 5 upon 6. So this value of lambda we need to substitute in the OP vector here. So we will be getting so 2 plus minus 5 by so this is 7 by 6. Thirteen by 6, 5 by 3 here. For the length, we have to find the modulus of this. We will write 7 by 6 whole square plus 13 by 6 whole square plus 5 by 3 whole square. So now when you solve this, we will be getting here 53 upon 6. So this is the solution of the given problem. I hope you understood the solution. Please like, share and subscribe this channel.